Yeah, it was the area problem. Okay. So, the premise is, we have that's where, no. There's 2, 3, 4, 5, 6. Alright, so we've got a square, okay? And what we see here is basically two parts. See that one there? I'll do my best here.
You don't have a line for that?
I don't have one for this. And the question is, if this is a shaded area, if we know this distance to be A, and we know this distance to be A as well, which is bigger? The area of the shaded or the green side? Now, this is an approximation. This is an approximation. Now, interestingly, and I think if you remember from my discussion over this on Friday, the graduate record exam is based on people having maybe taken calculus, but really all you would need is an Algebra 2 college algebra level, right? The things that you need to solve this problem, you got from me in geometry. Now, everyone but you. Now, the idea is, what we want to figure out is the area of those things. The problem we run into is it's not a designated space, other than it's outside of this curve. Now, the calculus brain in me says, well, that's really easy. This is a really easy problem because all this is the integral from 0 to A of something you haven't seen yet. This is, again, talking about how we look at problems differently and how we can, even if we don't know some certain pieces, we can kind of take it back to where it is, right? Problem solving aspects. Right? So I said, well, okay, this is a circle here, so I'm going to define this curve to be a circle. So that would be my radius is 1, or A for that matter. A squared minus quantity x minus A squared. Then I'm going to subtract this curve, this curve, which is the square root of A squared minus x squared plus A squared. Now, that's the calculus. But I said that we don't need calculus. It's an integral. Basically, like they're not area under. Now, what do we notice about these curves? Okay, they're wobbly. If I made them straighter, what would that be like? I don't know. I think I've heard it. I can't remember. Now, understand, this is bad Mr. Burdette's handwriting. All right? Let's say if I went in and I put these circles in here. Let's see. Right, there's 1, and 0. All right, so now, and I'm going to adjust here to kind of fix my look. squared. All right. Now, that changes things a lot, doesn't it? The moment I look at that as two circles, things are looking up. Say it again. It's a quarter of what? Quarter of a circle. Can you tell me what the area of a quarter of a circle is? Yeah. So this is 1/4 pi, and what's our radius here? What? That and radius our A, right? That's 1/4. Okay. Alright, so if I wanted this shaded area, what would I do with this 1/4 pi A squared? Here. If I wanted this area here, this little shaded, I wanted this shaded area right here. All right, very good. I'm going to subtract it from A squared, which is the area of that circle, or square, right? Because this is A and A. Agreed? So this area, so I'm going to call this the upper shaded. It's just going to be A squared minus 1/4 pi A squared. Right. Then that's the upper shaded. What's the area of the lower shaded? It's the same, wouldn't it? All right, so. So together, if I was going to do this together, it would just be 2 times that, right? So, let's do this. It's big shaded. So, if I multiplied that by 2, that would be what? You want to just do parentheses? You can. Or do you want to just go ahead and multiply it? Okay. So 2 times A squared is 2A squared. And then 1/4 times 2 is what? 2. Alright. So 1/2 pi A squared. So that's the area of the shade. Now, it's all mentioned. It all becomes. So that's the shaded area. Now, what's the question?
Keep on going, my answer.
Now, if that's the shaded area, what's the measure of the unshaded area? All right, so it's going to be A squared minus that again, right? So we do unshaded. So the unshaded area is going to be A squared minus 2A squared. Now I'm going to distribute that negative in, okay, because I'm subtracting A squared minus that whole thing. All right, so that becomes plus 1/2 pi A squared. All right, so A squared minus 2A squared, negative A squared. So if I was going to rewrite this, I'm going to leave that. Technically, I should probably put that at the end, but I'm going to leave that out front. So negative A squared plus 1/2 pi. So kind of a weird deal here, right? Because, well, don't quite know where I'm going with it, right? Because I should be at a place where I can make the sense of it. But I'm not really in that. What is it? Okay, so there's two options here. Very good. All right, one of our options is to put something in for A. Right? And actually, in thinking through this, when we see a problem like this, dealing with variables, especially when it's a geometry style thing, plugging the number in is okay. A lot of times you don't think it is, but a lot of times you can do that, save some energy, right? So, what would be the easiest A we could plug in? One. Right? 1 would be really easy, because, so if I say A is equal to 1, now I've got -1 plus 1/2, right? Agree? Right? Here I have 2 minus 1/2. So the question is, which is bigger?
It's shaded. That's it.
Where are you?
What?
This ends up being what we end up seeing here is that these two end up being equal. Now, going through it, it doesn't seem like that's the case. And when I did this problem on my own, I decided that, well, I was just going to do the calculus method, and I cheated and used my calculator to do it, and I got the same answer twice. I was trying to figure out what was going on. And so I went through and I solved, and it wasn't until I started going through and actually looking at what we solved for circles that I was able to see the answer. Now, there's some approximation effort to it. Right? So it turns out the answer is a little bit off. But for the most part, this is easy. And it's all based on this very basic methodology. Right? The fact that we knew we had a coordinate circle, the fact that we knew we had a square. Right. Huh? Consider that sense. Okay, that's the approximation. If you add those two up, we'll go. Yeah, it is a kind of a fascinating deal that there's that approximation effort to it, because this ends up being, this one is the 0.42, or 0.43, so this is,
No, that's a point.
yes, 0.43. So there is some approximation error to it. And so what we do is we say, well, we're going to call it this. That's approximation. Congruence is one of the. Alright, pretty cool, huh?